Welcome to Elimination! So exciting, like this is the peak of our algebra. This is as close as we get to what it's like at the high school. So fun. You've done so much work. It's amazing how far you guys have come. All right, let's do this thing. Here's what we got here. We're going to solve systems with elimination, so it's our third thing that we could do. So we've got how can elimination. Oh, this is tough to do with the packet like that. I don't know how you guys do it. You're amazing. How can elimination help you solve a system of equations? Right? How can elimination help you solve a system of equations? Now, when we do this, we're looking at a very, very interesting thing here to me, because in my mind, this is not the greatest thing in the world, but we're doing what we're doing to make it work for us. So this is Remy here. She's solving a riddle, and her riddle is this: 2 times the number x plus the number y equals 8. Well, that's equation right there. 4 times the number x minus the number y equals 4, right there. Okay, so we need to solve this to figure out what we're looking for in terms of what x and y will make both equations true, or where will those two lines intersect without using a coordinate plane. Okay, let's look at what we've got here. How can Remy use this system of equations to solve that riddle? Let's look at this first, right? This is just the same equations that are above. Is there one of these variables that seems like it would be easier to eliminate? Now, I don't even want to tell you about elimination yet. Take a guess, circle one of those. If you need to pause and decide, do that now. Then, let's look. Hopefully, you just took a stab at this. And if you didn't say why, that's fine too, because we're just guessing now. You might pick this because we have a positive y and a negative y. And a positive y and a negative y would eliminate each other. They're just like opposites. If we go back to when we learned about opposites, if I have 5 and negative 5, those two numbers, when they come together, they become 0. They disappear. So we're going to look for y, and what we're going to do is we're going to end up combining these. We describe this as linear combinations to eliminate one of the variables. Okay, for linear combinations, what we're doing there is, I'm going to put a little exclamation point. Linear combinations! We can add or subtract equations from each other. Now that seems wild, right? Seems like, what are you talking about? We can add and subtract equations from each other. There's a couple things we got to remember. First of all, both those x's, if we remember this, are the same. Both those y's are the same. And because that's the case, we can put those equations together. So what are we looking for to make this work well? Right here. Well, what we need is we have to find opposite x's or opposite y's. Either one of those is fine. And we can then eliminate one of those variables and then solve for the other that we don't know. So let's combine these now. If I put a little line here. Now I don't want to say add, but when we look at this, I'm going to put the signs in here so we know what we're combining. So I'm combining positive 2x and positive 4x, which is going to give me positive 6x. If you want to put your plus out here, that's fine. If you don't, that's okay too. I've got positive y and negative y, which equals 0. So that is taken off the equation. And we set that equal to positive 8 and positive 4 gives us 12. Now we have a simple one-step equation that we're going to solve for x. We have x equals 2. At this point, we are halfway done. Let's take our x, and we're going to plug it back into the other equation. 2x plus y equals 8. So I've just taken this equation and written it down here. My x is going in for x, and I'll say 2 times 2 plus y equals 8. 4 plus y equals 8. If you go back to your first grade brain, 4 plus what equals 8? Well, we know it's 4, but let's mathematically show it. Y equals 4. And now we can write our ordered pair. The solution for that equation was 2, 4. Right? We eliminated one of the variables, and then we solved for the remaining one, used that solution to solve for the original. Now you may be wondering, if we put this back into the other equation, would that work? Of course it would. So if I put 2 in for x here, I get 2 times 2 is 4. Or I'm sorry, 2 times 4 is 8. Well, let me just do it. Let's do it instead of me talking about it. Let's just bring this over here. What we should get is the exact same value, equals 4. So I'm going to put 2 in, minus y equals 4. 8 minus y equals 4. Subtract 8, subtract 8. Oh, we got to do a little twist here at the end. Negative y equals negative 4. Okay, did we want to know what negative y is? No. So we're going to multiply the whole thing by negative 1. Negative 1 times negative y is y. Negative 1 times negative 4 is 4. And that's where we get our 2, 4. Okay, flip it over. Let's do the next page. All right, that first part's pretty easy because they're giving us the elimination right off the bat. Now we don't necessarily have it. So we have an example here. We're going to solve by subtraction, but I don't focus on subtraction. Think of it as combining, and we're just checking to see the signs of these numbers. Hannah is helping her younger brother to learn to count money. She gave her brother a total of 20 coins that are nickels and dimes. That's this equation. Or nickels and pennies, sorry. So we got pennies, nickels, and the number of coins. Hannah's brother said he counted 68 cents. How can Hannah solve a system of equations to tell whether he counted correctly? So here's the 68 cents. Now the difference between these, this is a classic setup for a systems of equations problem. We have a number of pennies and a number of nickels and then a total number of coins. We have a number of pennies times their value. What's a penny worth? 1. We have a number of nickels times its value, 5. And a number of cents that it's equal to. Do we have an obvious elimination here? We do not. If you had to choose between these two, which one would be easier to eliminate? Well, at this point, I'm going to lean toward the x's because they're pretty similar. They have the same coefficient. But before we do that, I want to show you something about equations that we can do. If I have 2x plus 4 equals 8, what does x equal? You're absolutely right. X equals 2. Now, what I need you to understand is that whatever I do to this equation, if I do it to every single piece here, it will not change the value of x. X will still equal 2. So if I multiply all of these by negative 1, I've got negative 2x minus 4 equals negative 8. Will 2 still make this true? Yes. Negative 2 times positive 2 is negative 4. Negative 4 combined with negative 4 will give us negative 8. What if I multiplied the whole thing by 10? And I said negative 20x minus 40 equals negative 80. Will 2 still make this true? It will. Yeah, woo! Negative 2 times negative 20 is negative 40. Negative 40 and negative 40 combine to be negative 80. So we can manipulate these equations as long as we're true to the equation. We're making sure that we're doing everything equally to all the terms. So now we're going to do this. We just need to multiply one of these by negative 1. When we do that, we're going to flip a switch to make one of these negative x. Positive x and negative x would be 0, which would eliminate the x term. Now you have a choice here, right? Either one we could do. If we make the top one negative, we'll do 68 minus 20. That sounds pretty good. If we do the bottom one as negative, we would do 20 minus 68. That sounds more complicated. Now, either way we do that, we're going to get the same answer. But for ease of effort, let's just do the top one. So I'm going to rewrite this, I'm going to write this, x plus 5y equals 68. Then I'm going to rewrite this one after the multiplication. negative x minus y equals negative 20. Now this is why I hesitate to say add or subtract, because we're putting these together here. I've got positive x and negative x, which is 0. I've got positive 5 and negative, what's that coefficient there? You're right, it's 1. Positive 5 and negative 1 leaves me 4y. 68 minus 20 gives me 48. I've got a one-step equation going back to 6th grade. Divide both by 4, I get y equals 12. How much have I finished? Half. Let's bring down one of those equations. I'm going to do this one. X plus y equals 20. Take our y value, put it in for y. Make sure it's y going in for y. Okay, don't put it in for x, put it in for y. X plus 12 equals 20. Minus 12, x equals 8. The next thing, like these little details you got to remember here. We're going to make our ordered pair. Don't forget, this is x, this is y. Make sure you put x where x goes, y where y goes, so this has to be the 8. And this has to be the 12. Right? Great. So that's our solution. That's the only pair of numbers that will make both of those equations true. One more to go! So this is the big kid version of this, right? This is where we're going to solve the system with multiplication. This is where we're going to scale those things up. Like we did some multiplication right here, but in this one we've got to do multiplication also. This one doesn't even give us the equation, so we got to figure that out. The difference of the length and width of a rectangle is 3 centimeters. Okay, so that's our first equation right there. I've got length, and I've got width, and I need the difference. What does difference mean? You're right, it's minus. Length minus width equals 3. I go to the other one here. Oh, we don't even have, okay, we got this. What's that mean? Really good. That's perimeter. Boop. The perimeter is 26, so we know that's going to equal 26. How many lengths are there? Please, I hope you said 2. There are 2 lengths, not 1. Math teachers love that. They absolutely love kids to mess this up for perimeter for some reason. How many widths? You're right, there's 2 widths. And for perimeter, we just add them together. Okay, we've got our system. When we look at that, what are we going to do? Okay. Do we have one where it matches? No. Do we have opposite variable terms? Yes, we have opposite w's. So let's do this. What could we multiply this first equation by to get the opposite of 2w? Well, of course, we're going to multiply it by 2. When we multiply it by 2, we're going to get negative 2w, which is awesome. That will eliminate the w's for us. So don't be 8th grader me, be awesome 8th grader you. Multiply here, you get 2l minus 2w equals 6. Don't forget to get to that 3. 8th grader me would have written it right on there and totally screwed it up. Now I'm going to do this. You don't have to do this, but I'm going to put a line just through this right now. So we're not using that equation anymore. We have an equivalent of it right here. Now I'm just combining my linear, this is my linear combination time. I've got a positive 2L and a positive 2L, which is going to give me 4L. I've got a positive 2W and a negative 2W, which is going to give me 0. And then I've got a 26, a positive 26 and a positive 6, which gives me 32. Divide by 4, 6th grade problem again. We got the length is 8. Okay, let's take that and put it back in an equation. I'm going to use this one right here. Why not? Nah, let's use the smaller one. Length minus width equals 3. 8 minus w equals 3. If you switch back on that 1st grade brain, 8 take away what is 3? We find out that w equals 5. Now, all right, so I skipped a little thing here, so let's just look at that. If I have 8 minus w equals 3, technically I'm subtracting by 8 on both sides, and I'm left with negative w equals negative 5. Do we want negative w? No, nobody wants negative w. Everybody wants positive w. So multiply this by negative 1. beep boop, which flips everything to be W equals 5, which is what we knew it was. All right, this is giant. This is our baby. This is what we've been working for 6 months. So if you have questions, of course you do. We're going to practice it. We're going to work on it. We're going to get us to be as good as we can be. Just put the reps in. You'll be great. If you have questions, please let me know. Okay, guys, good luck.